chapter units and measurements. Dear students, +1 physics. The chapter begins with units and measurements. So when we discuss about this chapter, we are in our daily life. We use many cases the measurements and its units. We are supposed to say that when we purchase something from the shop, suppose rice or milk, we used to say the measurements, right? As we know that we used to say shopkeeper that 5 kilogram of rice, give me 5 kilogram of rice. Okay, so 5 kilogram, 5 kilogram just a minute. Five kilogram. So this 5 represent the value, quantity. How much quantity of rice you require? Then what is this kg? We used to say 5 kilogram, right? So this kg is the unit which we represent. So 5 kilogram is the total amount that we used to represent. Same way, 2 liter of milk. So what is 2? 2 is the value and liter is the unit, right? So this all we used to do in our daily life activities. So the same thing that we are going to discuss in this chapter 2. So in our physics, we are using many physical quantities for doing our experiments of many cases. So as we know that measurement is very important. Measurement is very important in our physics studies. So we can say physics is a quantitative science. Physics is a quantitative science. What does it mean? We require a certain quantity for every purposes. Certain quantity. Quantity is very important. So physics is a quantitative science based on measurement of physical quantities. We used to measure temperature, right? Temperature, time, how much time to complete one process. We used to measure length, 1 meter, 2 meter, 20 kilometer, etc., etc. So these all we use. We are using in different cases. So based on these measurements, physical quantities, certain physical quantities have chosen as fundamental or base quantities. Fundamental or base quantities. Fundamental or base quantities. The fundamental quantities that are that we chosen as length, mass, time, electric current, thermodynamic temperature, and amount of substance and luminous intensity. These are the 7 fundamental physical quantities. So this we call it as base quantity or fundamental units. Base quantity or fundamental units. Each base quantity is defined in terms of a certain basic arbitrary chosen, but properly standardized reference standard called unit, such as meter, kilogram, second, ampere, Kelvin, mole, and candela. We can see here length. Length represented by meter. Mass represented by kilogram. Time represented by second. Temperature represented by kilogram. Electric current represented by ampere. And luminous intensity represent candela. Sorry, here one wrong. It's not kilogram, it's a Kelvin, okay? Please be correct. Temperature represent Kelvin and it represents capital letter K. It's not kilogram. Please be keep in the mind. It's wrong. Okay. Next, amount of substance represent mole. MOL. Mole. In chemistry, we used to do the problems. Amount of substance, 2 mole of substance, 5 mole of substance, etc. So these are the fundamental units or the fundamental quantities. So uh, 7 fundamental quantities are there. With addition to that, 2 supplementary units in relation to quantities, that is plane angle and solid angle. And plane angle represent unit radian. In the coming page, it is already written there. And solid angle represents sterdian. Sterdian. Okay. Plane angle units is radian and the solid angle units is sterdian. Okay. So let's see the next page. We can see. Sorry. Okay. Okay. When we come to the next page, you can see here plane angle, that is radian, and solid angle, that is sterdian. So what is plane angle and what is solid angle? We are going to discuss in coming topic. Before that, we need to know the derived units. What is derived units? Derived units, we are getting derived units from the combination of the base quantities or the fundamental units, what we discussed earlier. Just we discussed before. So the fundamental, these derived quantities are other physical quantities derived from the basic quantities and can be expressed as a combination of the base unit. Okay. Here 2 examples given: volume or density, etc. Okay. So when we discuss the volume is equal to length into breadth into height, right? So length we represent meter, breadth we represent the unit in meter, and height is also a meter. So volume is equal to meter into meter into meter, meter cube. This is the representation for volume, unit representation for volume. So this meter cube is a derived unit from the basic quantities, that is length. So we know that length is measuring by the length. So its unit is meter. Same way, breadth is also measuring by a tape or scale or whatever. So that is also, its unit is also a meter. And height is also we measure by the unit of meter. So meter into meter into meter, meter cube. So this meter cube is the derived units which comes from the base quantities of the length. Okay. Same way here, density. Density we can represent by letter rho. Density is equal to mass per volume, right? Mass per volume. So we know that the mass represent what? Kilogram, right? Mass represent kilogram and volume represent what? Meter cube. Just before we discuss, so kilogram divided by meter cube, that is equal to kilogram meter raised to -3. So this is the derived unit for the density. Okay. Same way we can find out the unit for the velocity, acceleration, force, etc. Whatever. So all other units are derived from the basic quantities. That's it. So once again, derived units, which means that is derived from base quantities and can be expressed as a combination of the base units and are called derived units. Hope everybody clear. Okay. So now next we are going to discuss international system of units. International system of units. In science, different countries, they are contributing to the science, right? Different various parts of the world, different countries are contributing to the science. So suppose the Indian scientists and Italian scientists, they are doing the same process, but if the units are not matching. If the what the Italian scientists are doing that those representation of units, suppose if we don't know, Indian scientists suppose if they are not understanding, how do they collaborate? It's not possible, right? So in ancient days, different units are supposed to be here in different way in different countries. So to make it a unified system, it's common to all. They started to represent the units in an international system of units. International system of units. And in the international system of units, based on 7 base units at present, internationally accepted unit system. That is important. If these units are internationally accept unit system and is widely used throughout the world in computing any physical quantities. It's widely used throughout the world in computing any physical quantities. The units are derived quantities involved in the relationship are treated as though they were algebraic quantities till the desired units are obtained. Now, here for example, SI system, this international system of units we represent by SI system of units. For example, here it is given CGS system, CGS. My board has some issue. CGS system, it's not okay. CGS system, FPS system, MKS system, SI system, right? CGS system, FPS system, and MKS system. Okay, so in the CGS system, we use centimeter, C for represented for centimeter, mass for the mass it's gram, and for the time it's second. And FPS for the mass it's for the length it's foot, and for the mass it's pound, and for the time it's second. And MGA system for length it's meter, and mass for kilogram, kilogram for mass, and the second for time. Okay, so the SI system. This system contains 7 fundamental units and 2 supplementary fundamental units. The SI units are used in all physical measurements for both the base quantities and the derived quantities obtained from them. Certain derived units are expressed by means of SI units of special names such as joule, Newton, watt, etc., which represent joule. Joule, we know that the joule is the unit for work, right? And Newton is representation for the force, right? And watt is the representation for the power. So these are the SI unit for work, force, and power respectively. Got it? But uh, when we derive, suppose for the Newton, what is Newton? I couldn't. Okay, we know that the Newton, which means what? It's a unit of force, and F is equal to ma. Unit, equation for force F is equal to ma. That for mass, kilogram, and for acceleration, L t raised to minus 2. Sorry, for the acceleration, meter per second square. Okay, so kilogram meter per second square is the unit for the force. At the same time, this kilogram kilogram. My writing board has some issues. Please sorry. So kilogram meter per second square. This is nothing but square. This it's nothing but is we totally represented as 1 Newton. So this Newton is also considered what? SI unit. Okay, so that's it. Very simple. Next, we are going to discuss about the two supplementary angles, units, that is plane angle and solid angle. Okay, so plane angle. So here plane angle, which means you just imagine uh, the angle which make in a plane, the angle which make in a plane. So just for an example, if we say the wiper, car wiper, we know that the wiper swipes a particular area of the glass, right? When the wiper rotates, it swipes a particular area of the area of the glass. Okay, so it makes an area. That area, the plane area, that we represented as ds. Okay, that we represent as ds, and the angle which made by the plane angle is d theta. So d theta is equal to ds divided by r radian, and it is called as plane angle. Okay. And for the solid angle, I used to represent an example for the solid angle is, suppose if we take a knife, plain knife, and we cut the watermelon by cutting in this way, this way, this way, this way. What will happen? We may get one piece of watermelon like this, right? There will be a corner. There will be a corner which all these uh, plane of all the four sides of the plane is joined. That will be look like the circumference, and it makes an angle d omega. And the plane surface that we are getting as dA. So in that case, d omega is equal to dA by r square, and its unit is stereo. So plane angle is basically a two-dimension. Okay, you have to be think. You need to imagine as in an angle make in a plane. Okay, and solid angle, which is nothing but the angle which develops in a solid. Okay, just we I already discussed about the watermelon. Okay, when we make a piece of watermelon in this way, you may get a solid angle. Okay, so that is what the difference between the plane angle and solid angle. Just keep this unit in the mind. Plane angle unit is radian and solid angle unit is radian. Okay, we will continue this journey. Please be tuned with SMF, everyone. Okay, thank you. I am writing this session here. Let's see in the next class. Thank you.